Hello, my name is Kerstin Denecke and I'm here together with Tödtli. We are co-organizers of the workshop Artificial Intelligence in Healthcare that takes place in April. And with this short video, we would like to introduce machine learning in healthcare and its applications. So let's start.
So, what is machine learning? Machine learning is a software black box that learns patterns from data. In supervised learning, these training data are annotated somehow, often with concepts for which it is hard to explicitly formulate patterns. So training data is used to explain to the black box which patterns we are looking for. Machine learning is all about generating these patterns from examples and trying to generalize them beyond the training dataset. Machine learning can accomplish different tasks. Classification, for example, predicts distinct classes, such as whether a patient is healthy or not. Regression estimates or predicts a value. And clustering groups items together. There are many other tasks, such as learning to rank items for recommendations or to detect instances that are somehow different from the known examples. A distinguishing feature of these tasks is how we measure success. In supervised learning, this is often quite clear. For example, to measure the success of a classification system, we ask how often is the system guessing correctly. To measure the success of a regression system, we ask how well did the system guess? That is, how close was the system's guess to the true value? Unsupervised learning, in general, identifies patterns in data, helps us to better understand the data or to represent the same data in an insightful, novel way. The patterns found in a clustering task, for example, are not always easy to interpret. Therefore, in unsupervised learning, success is often rather difficult to measure. Nevertheless, being able, for example, to parameterize CT scan images as a subspace of all possible images may help to improve on a supervised learning task.
You remember machine learning needs data where it can learn patterns from. So in the medical domain, we have many different kinds of data. There are, for example, texts like documents. We have finding reports, discharge summaries, progress notes. But there are also image data like an X-ray image. Or we have a couple of measured values like blood pressure, laboratory values. Or even the duration of a surgery is a measured value. Then we can have time series like a long-term ECG, as you can see it in the picture. And of course, machine learning can use multiple data types to learn patterns from. Let me show you a few examples where machine learning can help healthcare professionals. So one example is to use machine learning for letting create suggestions of ICD-10 encodings. So in this example, we are using some clinical documentation like a finding report, discharge summary, and the algorithm makes suggestions of possible encodings of the ICD-10 encoding system. The physician only has to select an appropriate code and that's it. So this could speed up the encoding process. Another example is to use machine learning to detect what is abnormal. So we can use images of CT scans of the lung and the algorithm learns what are usual patterns and what are unusual patterns. When we use additional data like symptoms of a patient, age, whatever, then we can let the algorithm create clusters of patients and could identify patients that are similar to the one I am currently under treatment. And in this way, I can learn from the data of other patients regarding the treatment for my current patient. The last use case I would like to show you is to use machine learning for predicting the occurrence of delirium. This particular algorithm here uses diagnosis, procedures, laboratory values, and other data to predict the risk a patient has in developing delirium. And as a result, it makes a judgment whether the risk is very high, high, or low. The interesting thing here is that on the screen, so the system is actually running already in the hospital, the system shows which was the data that was used by the algorithm to come to the decision, which in turn helps the physician in judging the reliability of the prediction of the system.
So machine learning can work on many different types of data, but machine learning projects also fail quite often, and they can fail for many reasons. Here are a few things to consider when developing a new idea for a machine learning project. First, whether the data contains the patterns needed for success and whether machine learning will find them can be difficult to predict. Do a quick experiment instead. If it is difficult for you to think of any connection between the data and the target label, then you might expect poor results. Also, when thinking about employing applied machine learning in a novel situation, make sure to double-check that the use case is ethically justifiable. Also, check its legal usability and social acceptance. For clinical applications, for example, AI results might have to be explainable. Patients might have critical questions on why that black box decided the way it did. So it's clearly easier to focus on tedious, semi-intelligent tasks. Machine learning is particularly good at helping humans to select or decide, and somewhat less so in deciding for humans. Good candidate applications for machine learning are making a pre-selection, such as suggesting interesting documents, or warning a human of an unusual instance to revisit, a mistake, a fraud, a new trend, etc.
So now it's up to you. Think about novel use cases you see in your clinical practice, and we would like to discuss them in the workshop taking place in April. So see you there.
Bye.